Follow Shadow Junior Twin.
Hello everybody, I hope we're all enjoying summer. Maybe you've been bedrotting, maybe you've been productive, maybe you are on holiday, maybe you're going on holiday. Either way, there's always time for some computer science. If you disagree with me, just give me a couple minutes of your time. Hopefully I can explain this quite popular but interesting problem. So we have the coin swap problem, which is a basic problem when we're doing dynamic programming, which is an interesting data structure and algorithm which you will cover at university. So let's say we have the following coins, right? We have 1p coins all the way up to 20p coins in this list, right? And we're tasked to find the number of ways you can create the total of £5. Okay, so how can we do this? So first of all, I've already mentioned we're using dynamic programming. Dynamic programming is typically used when we can use the results of multiple related subproblems, right? And here we have a mock array. This is an abstraction because we don't have all the columns required. I'm going to explain what's going on here in a second, and then you can see how it's a relation of multiple different subproblems. So first things first, what is this top left index and what is this bottom right index? So the bottom right index is actually what we're trying to find. We can use all of the coins and the total is 500p, right? Which is equivalent to £5. The top left index is a total of 0 and we can use 0 coins. We don't have any coins at our disposal. So this random index here is going to be a total of 2p, and we can use the coins 1p and 2p, right? So what this array is doing is we have a column for each of the sums from 0 all the way up to our target total, which is 500. And then the rows, we have a row for all the different number of coins we can use. So we can use 0 coins, we can use just the 1p and the 2p, the 1p, 2p, and 5p in ascending order. And each time we add a new coin to our row, our final row is going to include all the possible coins we could utilize, right? So first of all, what can we fill out in our 2D array? Of course, this ellipses is here because we can't write out all of the columns required. This should be 0, 1, 2, 3, all the way up to 500, but I'm not going to write out that many columns, don't be daft. Okay, so what can we fill out? So first of all, this top left index, we're looking for a total of 0p and we have 0 coins to do so. Well, there is one way to do this. And it's the only way to do it, right? If you're looking for 0p, you just use no coins and you have no coins, right? So there's only one way to do this. What about all of these columns here? They all share the same number and it's just 0, right? If you have no coins, you can't make 1p. If you have no coins, you can't make 2p, and you can't do that for any of these columns here. What about this column 0 and all of these rows? So if you're looking for a total of 0p, no matter the number of coins you can use and how much value they have, you can do this in one way. You just use no coins. If you use no coins, you have a total of 0p, right? So that's what we can autofill out. But other than that, we have to use a specific formula, right? And this formula relies on something special. So this is what's going on here. Let me just explain it quickly. Let t just equal this array here, right? So this t is just getting an index within this 2D array. And c, in this case, which is utilized here, just represents our coins, which is 1, 2, 5, 10, and 20. So what are these two searches actually doing? So this one here is essentially saying, what if we don't use this new coin we've added in this new row? And this search here is saying, what if we do use that coin? What do we do? So first of all, what happens if we do not use the coin we just added? First of all, that's because these are the only two things we can do. We either use the coin or we don't use the coin. So if we do not use the coin, well, we just need to go back a row, right? For example, let's look at this third row here. We've now added the 2p coin from the previous row, which doesn't have the 2p coin. So if we don't use the coin we just added, we have to look at the same column, but just go back a row, right? That's the number of ways we can do it if we do not add this new coin. That's how we get t row -1 and then column. What if we are using that new coin? So let me just create a mini scenario to explain this better. And let's say we're looking for a sum of 5p and we have the coins 1p and 2p at our disposal. So if we're looking at the number of ways we can create 5p and we're using the 2p coin, we already said we're using the 2p coin. What we want to do is we want to say, okay, our target is 5p. We're going to use at least one 2p coin. So we're going to do 5 minus 2, right? This means we're utilizing at least one of these new coins. And we get the sum of 3, right? That means we now have a remaining total of 3p. We've already used one 2p coin, so we still need to make 3p. So what we then do is we look at the number of ways we can create 3p, right? So that's why we have this search going on, and this is why these subproblems are related. It's kind of like recurrence relations a little bit, but yeah. So that's why we're doing column, because in this case, column is the target total, minus C, which just represents the coins, row minus 1. The reason we do row minus 1 is because in this case, row 0 is just no coins, right? And row 1 is the first coin. But in this case, C doesn't contain no coins, it just starts with 1. That's why we do row minus 1. But in reality, we're just doing, if we add this new coin, what's the remaining total we need to create? All right, hopefully that makes sense. So what we're going to do is we're going to repeat that for all of our indexes in this whole 2D array. And this bottom right column is going to be our answer. This bottom right index is going to be our answer. It's going to contain the number for the number of combinations to create 500p using all of these coins. So let's look at the code for this. Let me zoom in a little bit. So we have our coins array, we have our total target, and we're going to create our 2D array called DP. So this is going to be a 2D array initialized at 0, and we have 6 row count and 501 columns. The reason why we have 6 rows is because we have a row for 0 coins, and then we have a row for 1, 2, 3, 4, 5 coins. So that totals 6 rows, right? And the same thing for column. We have a column for a total of 0 all the way up to 500. So that's why we have 501 columns, right? And then we're going to do the initializing that we did ourselves, where we set all of the first column to 1 and all of the first row bar this top left index to 0, right? We're doing the same thing ourselves. And the reason why we do the 1 afterwards is because we need to override these. Actually, no, we started with 1 up here, so it's fine. Okay, perfect. So now that we've done the initializing, we need to set up the loop. We need to loop through all of the indexes in this whole 2D array and do the little calculation that we mentioned. So we're going to look at using coin, right? Using coin is going to be that second calculation we looked at where we know we are going to utilize the coin, okay? So something that we do need to consider, which I actually didn't mention, but I'm going to mention it now. If that calculation is less than 0, right? If this calculation here is less than 0, we're just going to set it to 0. Basically, that means we cannot use this coin to create the sum. For example, if we have a 20p coin that we can use, 5 minus 20 is obviously less than 0, meaning we cannot use this 20p coin at all. There's not even a point considering it, right? So if using coin is less than 0, we set using coin to 0. If negative, we set it to 0. That's my little comment there. And then what we're going to do is we're going to do the update that we said here. We have dp row minus 1 and column, and then we have t row minus 1 column, and we have the using coin calculation. And then we're going to repeat this for all of the indexes in this 2D array. We're then going to print the very last index in our 2D array, the bottom right corner. And what we get in this case is, what's this? 1,510,301 ways to create the sum of £5 using these coins. Quite a lot. You probably wouldn't expect that many combinations, but there you go. Hopefully this was a good explanation video, and good luck revising. Well, not revising. Good luck preparing for uni.